Welcome back to another lesson in physics. We are continuing our coverage of Unit 3 on kinematics, the study of the description of motion. Today's lesson is on scalars and vectors. We've talked about a few quantities in physics so far. You've measured volume and you've measured mass. You'll be determining velocity here in the near future. And then there's force, and there's going to be time and acceleration and position and displacement and electrical potential, index of refraction, torque, work, energy, density, sound intensity, luminous intensity, magnetic flux, power. Wait. Let's back up just a little bit. Okay, let's look at just volume, mass, force, and velocity. And let's rearrange them. On the left, we have volume and mass. These are quantities that have magnitude or size only. The number associated with them describes a particular property of an object. We call quantities that have only magnitude or size scalars. The quantities on the right, force and velocity, have magnitude, but they also have direction. If you were to say that you were going to drive at 50 miles per hour, that tells us how fast you're going to be going, but it doesn't tell us which direction you're going in. And so we have no way of predicting where you're going to end up. For these quantities, like force and velocity, direction is an important aspect of the quantity. And we call those types of quantities vectors. So a scalar is a quantity having only magnitude. Other examples include time, density, charge, work, and energy. Vectors have both magnitude and direction and include things like position, displacement, and acceleration. In freshman physics, we worked with vectors in one dimension, and we used a number line, and we established a frame of reference by establishing an origin or a reference point on the number line. And we made the convention that vectors that extended to the right were considered positive vectors. And so we denoted vectors directed to the right using the positive sign. And vectors directed to the left were indicated using a negative sign. When we wanted to add vectors together, and we'll use our example of a positive 4 unit vector and a negative 2 unit vector. When we wanted to add them together, we did this by translating or moving one vector so that the tail of that vector was adjacent to the tip of the other vector. And then we drew our resultant vector, or the sum of the two vectors, from the origin of the second vector, or the tail of the second vector, to the tip of the first vector. And that value, that length of the resulting vector, was its magnitude, and in this case it's a plus 2 units. And so for vectors in one dimension, simple arithmetic allows us to add them together. Plus 4 units plus a negative 2 units gives us plus 2 units. Vectors aren't the only things with signs, though. Some scalars have signs, but the sign on a scalar serves a very different purpose than the signs we were talking about associated with vectors. For scalars with signs, the sign indicates the quality of the number. For instance, we have positive and negative charge. That doesn't mean that things with positive charge go in one direction and things with negative charge go in the other direction. It means that there's a fundamental difference between the properties of positive charge and negative charge. We also talk about positive and negative work, but work doesn't go in this direction or that direction. Instead, by agreement, positive work is generally work that is done on a system, and negative work is work that is done by a system. And finally, some temperature scales have both positive and negative values. That doesn't have anything to do with direction. It's just a way of orienting a certain temperature with respect to the standard that is based upon the freezing point of water. So we know that negative 10 degrees Celsius means that that's 10 degrees below zero, and positive 10 degrees is 10 degrees above zero. So scalars can have signs, but those signs do not indicate direction. Okay, so let's wrap up. We've talked about how quantities of physics are either scalars or vectors. We've also talked about how vectors have the property of direction. Vectors in one dimension are represented by arrows on a number line, and that adding one-dimensional vectors is simple arithmetic, and that some scalars have signs but not direction. So, until next time, have a great day.